about to go into complex half reactions. It's very important on a test or a quiz you watch the wording. Does the question say balance the complex redox reaction? I may use the word full, or most likely I'll say balance the following redox reaction. Okay? You're not using the table, you're going to use oxidation numbers. Or the question might say balance the half, where you've got to do this slightly different list. Okay? That's just the most important suggestion guideline I can give you, is separate the two out. So when you balance the half, you deal with the electrons at the very end. Okay? And I'm going to jump right into an example. Okay? So we have nitrous, not ick, but if. Acid can react in an acidic solution to form nitrogen monoxide gas. Okay, I want to know if this is an oxidation or reduction, so we got to balance the half, see where the electrons show up. Okay. The first thing that should jump out at you is I'm asking about half, so we'll deal with electrons last. We're going to balance the atoms other than O and H first, O with water, H with H plus. And then we've never seen this before, but we're going to add electrons to balance the charges. So we're going to have to do a new list. We're going to add up all the charges on both sides and neutralize it or balance it. So I took the words and got a skeleton reaction. Skeleton is just pieces. It's not a balanced reaction. So I'm going to start atoms other than O and H. So that's just nitrogen. The nitrogen atom has one at the beginning and one at the end. So I have nothing to do to fix nitrogen. It's already balanced. I'm going to balance oxygen by adding water, if necessary. If it's a tie, I don't have to add any water. I'll do this orally instead of doing a chart because the table is so low. I'm not going to do right side, left side visually or written out. We got two O's at the beginning. We only have one at the end, so I need another water. So this is the low side. This is just like we did with the complex redox reactions. So that's done. These half steps are super fast. They're like 1/10 the length of doing the fulls. There's no oxidation numbers. Balance H by adding H plus. We've got two H's at the end, and we've got one already at the beginning. So we need one more H at the beginning. I balance the H. Now we need to add electrons to balance any charges. So this is going to be my charge, and I will fix it with electrons. So we're going to count the charge at the beginning. I'm going to give a visual to this up above each piece. We have a neutral molecule with no charge. Okay. You might do that in your head. We've got H plus, and there's only one of them. We don't have to write the number in, but we have to realize there's one. So that's going to contribute a +1. So in total, for the reactants, we're a +1. Let's see what the products are. We have a neutral molecule, and water is another neutral molecule. There's absolutely no charge on the product side. We are going to add electrons, which are negative. We must take the high side and bring it down. Electrons can never cause the charge to go up. They can only cause the charge to go down. So what side is the higher side? Could be either one. In this case, it is the reactant side. +1 is greater than 0. We are not bringing things down to 0. We're bringing the high side to the low side, whatever those numbers happen to be. What do we need to get +1 down to the product side? We need 1 electron. We'll bring +1 down to 0. And then the charge is balanced. Okay? So we need 1 on the reactant side. So +1 electron. You don't have to write the 1. And we're done. So atoms other than O and H, OH electrons. So we can answer our question. Is this LEO or GER? Are we gaining or losing? Well, our electrons are a reactant. So this is a GER. This is a gaining. This is a reduction half reaction. Let's do that a couple more times, and then you can practice. So balance the following. That half has to scream at you. Take a highlighter, underline that word on your diploma or on a test. We're doing electrons at the end. We're not using oxidation numbers. We don't have the list right up on the board, but we're glancing back. Balance atoms other than O and H. That's done. Balance O with water. Well, we've got 4 O's at the beginning. We have none of them at the end, so we're going to need 4 water to balance our oxygen. So we're done 2 steps already. Other than O and H done, O is done, H. Well, all the hydrogen came from our water. There's 4 pairs. There's 8 hydrogen at the end, so we need 8 hydrogen at the beginning. 1 step left, which is balancing our charge. We've got to bring the high side down to the low side. The electrons could go on the reactant side or the product side. So we've got MnO4 minus. So we've got a 1 minus charge. We've got 8 H pluses. So that'll be 8 plus in total. We've got -1. We've got +8. So we have a total charge of 7 plus. Okay. This is where oxidation numbers are signed first, number second. Charges are number first, sign second. At the end, we've got a manganese 2 plus ion. There's only 1 of them, so that's 2 plus. And we have 4 neutral waters, no charge at all. It doesn't matter how many water we have, so we have 2 plus at the end. We need to bring the high side down to the low side by adding electrons. So that's going to be the high side. 7 is bigger than 2. So we've got to bring this down to 2 plus. So how many electrons? 7 down to 2 would be 5. 5 electrons will bring that down. Now we need to add them to the reactant side. And that should be balanced. And we can find out if we're right, because I stole this from your reduction table. It's the third half reaction from the top that we just reconstructed. MnO4 minus, 8H plus, 5 electrons, 1 manganese, 2 plus, and 4 waters. It's done right. This is where a lot of your half reactions came from. The H plus and the water came from these steps. Last one. We still have that heading of balancing half. Balance other than ONH first. That'd be chlorine atoms. There's one on both sides. Balance oxygen with water. We have 4 oxygen in perchlorate, so we need 4 waters. Balance the hydrogen. We've got 4 water again, so that's 4 times 2, 8 hydrogen at the end. So we need 8 hydrogen at the beginning, and it comes from needing to have some acids, some H+ ions. We've got lots of charges, so I'm not going to do that in my head. We've got a negative ion, so that's 1 minus. We've got 8+, so that's 7+, similar to the previous question. At the end, we've got a single chloride ion and a bunch of neutral water, so 1 minus. So we've got a positive number and a negative number. We always take the bigger side, the larger in magnitude, or the larger, and bring it down to the lower. So that is +7 is way bigger than -1, and we need that down. So 7 down to 0, and then down 1 more, so that's 8 electrons to do that drop. And I'm done. So I need you to do the complex half on the unit test and quizzes in like 2 minutes. The complex fulls might take you 5. There's going to be a big time difference. So let's see, that's the last one that I'm going to do. See if you can handle dichromate, Cr2O7, 2 minus, turning into chromium 3+. Both of these are aqueous. And the correct answer is right in your reduction table. 8 lines down on your table has the correct answer. Have the answer. So the answer to this one, balancing atoms other than ONH, is chromium. I now have 2 chromiums on both sides. I've got 7 water at the beginning. Sorry, 7 oxygen at the beginning, so I need 7 water at the end to balance O. Hydrogen, I have 7 times 2 at the end, 14 at the end, so I need 14H+ at the beginning. And then the most challenging part is not making a mistake with your charge. 2 minus, and then 14+ for the 14 H pluses. So that's +12. On the product side, 2 3 pluses, 6+, and no charge to water. So the high side is the reactant side again. We need that down to +6. So you need 6 electrons. Okay. You might put them at the end. Your reduction table always puts them at the end of the reactant list. I don't have room, and it's fine to put them at the beginning. The order doesn't matter. And that matches what's in your table. So that's balancing complex half reactions.